Unit 3.1. Let's take a quick look at the Boolean data type. We're going to dig in a little bit more into this Boolean data type. It's true or false, 1 or 0. 1 representing true or 0 representing false. Some languages actually use these in conjunction with this to represent the Boolean data type. If you think about it, a Boolean data type is a bit. 1 bit, that's the size of it, the true and false, 1 or 0. So Boolean happens to be the foundation of computing. One thing that Boolean expressions do is that they do compare similar data types. And the idea here is the comparison is either true or false. The comparison is done by using these little operators here. So we have the less than, the greater than, the equal to, not equal to, less than or equal to, and greater than or equal to. Now, one little thing about these last four here is that you shouldn't put a space between them. Okay, that's not correct. The two of these operators must be right next to each other without a space between them. Same is true here, and the same is true for the other two as well. So make sure that these are right next to each other. I have a last statement under here which is very important. These are good for comparing primitive types, not objects. All right, and we'll see that a little bit later as we dig deeper into this unit. But right now, objects generally provide what is called an equals method for the comparison. There are other types of comparison as well, but let's try to refrain from using these to compare objects. Okay, and we'll speak about that more closely as we dig deeper in. So here's some examples of comparisons, and we want to just look at what should be happening here. So x and y are both integers, which is nice because they're similar types, so we could compare them. The first one, the Boolean statement that we have here, says x is less than y. That's either true or false. So if we look up here, we would realize that 5, which is x, is less than 20. So solution 1 turns out to be true. Let's look at the next one, solution 2. X is greater than y. Well, that's not true because 5 is not greater than 20. So this is false. The third one, solution 3, we are assigning the answer from this comparison to the Boolean on the left. X is the same as y. That's not true because 5 is not the same as 20. X is not equal to y. That's true because 5 is not equal to 20. X is less than or equal to y. That's also true because 5 is less than or equal to 20. X is greater than or equal to 5. That's false because 5 is not greater than or equal to 20. So that's what we have there. And then we printed this solution to see what would print. And of course, just like in the earlier unit, if we put a string in between, it turns everything into a string. Okay, so let's make sure we get that clear. I only needed one string, but I'm doing this so that we get some space in between them. So solution 1 would be true, this would print false, and this would print false, and so on. All right, before I go ahead and run this, let's jump into the objects because this is a big deal here. When you're dealing with primitives like ints and doubles and Boolean lowercase b and all those types of data types, primitives, it's okay to use this type of comparison, okay, where we have less than, greater than, and so on. Once we start working with objects, though, which a string is, and if you could remember, this is the same statement as new string with the literal inside. I could make it like that, or I could make it like this. So these two strings, we have name and name2. I'm asking, and this is where we were talking about the equals method before. See, once we go to objects here, we got to use equals, not equal equal, okay? So if I do this, and I assign it to solution 7, is it true or is it false? Let's run it. So here's what we got. Let's go ahead and check what we printed and see if what we are suggesting here is right. We had true then false, true then false. We have false then true, false then true. Then we had true then false. Okay, so this works out nicely. Solution 7 says true. So the next question now is, why is it true? Well, it's true because this cowl and that cowl are the same. That cowl and that cowl are the same. So if I change this cowl to a lowercase c, for example, it should print false, and it does. It's not the name cowl, is the string literal, has the same characters in the same order. That's what this equals mean for a string. So let me put the uppercase C back and let's run it again. So right now the two names are equal, name and name2. What if I did this though? What if I say Boolean solution 8 is equal to name equal name2? And then I go ahead and print that just to see what would happen with solution 8. So if you're thinking about this solution, it looks kind of weird with the equals, but it's actually a Boolean expression on the right being set to a Boolean on the left. If I run this, what do you get? It says solution name equal to is true. Okay, so even though we don't want to use the equal to compare objects, it turns out that these two could be true. There is a reason why we don't want to use this though, this one. Okay, we don't want to use that because for two reasons. One, this is not guaranteed to give us the same solution. Okay, in this case here, it's true, they're both equal and it gave us correct. But if we run this in some situations, it may turn out to give us an answer that's not exactly correct. And so that's why we try to refrain from this. The dot equals is the one we use for all objects. Okay, so even though this one gave us the same solution, and you may think, well, I'm going to use that. Let's not do that. So I'm going to erase this. I just want to show you that it's possible to make the comparison, but it's not reliable. So the rule of thumb is always use dot equals for objects, equal for primitive. That's the end of 3.1.